Usually our topics deal with any one branch in maths, but today we have a multiverse. We are starting with the polynomials, which is a concept that you see in algebra. From there we are going to cross over to geometry. So let us start today's class. What do you see here? These are all polynomials in variable x. They are usually denoted as p of x. A polynomial in variable x. What you have here is a linear polynomial of degree 1. Any polynomial of degree 2 is called a quadratic polynomial. A polynomial of degree 3 is called a cubic polynomial. And the a, b, c, d that you see here, they are all real numbers. By real numbers, we mean that the rational numbers, the irrational numbers, decimals are all included. It can be any number, but one of the coefficients come with a clause. It comes with a condition. What is it? A cannot be 0. The coefficient of the highest exponent cannot be 0. Why is that? Instead of 2, suppose you have 0 here, then the whole term becomes 0. So instead of a cubic polynomial, you have ended up with what? You have ended up with a quadratic polynomial. So a, or in other words, the coefficient of the highest exponent of x cannot be 0. Now let us move on to the geometry part. Suppose I give values to the variable x and find the corresponding values of the whole polynomial. Then I will get such a table. What if I plot these values along the x-axis and these values along the y-axis? Let us see how that graph looks like. So you can see that when you start with any random linear polynomial and you plot the points, the graph you get, the figure you get is that of a straight line. It will always be a straight line. The position of the line may change. Maybe it comes this way or it cuts another way. The position may change according to your coefficients. According to the a, b and c, the position of the line will change, but it will always be a line. And when you are taking the xy axis, remember that the points always come in ordered pairs. That means 0, 6 is together one point. This point here together is that ordered pair. Now we go on to the quadratic polynomial. We plot this point, which is the origin, and this point, and so on. I have already noted down the points, and when you join it, you will see that the figure looks like this. It is called a parabola. It is a mirror symmetrical image, and it more or less looks like U. So remember, when you start from a quadratic polynomial, you will always get a parabola. Now the location of the parabola may change. Now this looks up. Some of the parabolas will look down. The width of the parabola may change, the location may change, but it will always be a parabola. And similarly, when you start from here, you can get a quadratic polynomial. Now before we move on to the next topic, let me ask you one question. What is the equation for x-axis? X-axis is the line that you have been drawing all your life. Since your junior classes, you use a ruler to draw that. Remember? Now this is the line that you have been drawing all your life. You just did not know that it is the x-axis. And what is it? It is just one dimensional. That means the points can just be denoted like this. They are just single, just points. But then here you will see what happens to the y. There is no y drama here. There is no need for y. Y is non-existent in this sort of scenario. But the same x-axis, when you move it and you bring it in a two-dimensional plane, then what happens? You will need to have what? You will need to have ordered pairs. Then what do? Just put 0 here. All these years your life has been going completely fine without the y-axis, right? So there is no need for all that drama. Just put 0, and that itself is the equation for x-axis. The equation for x-axis is just y is equal to 0. Similarly, the equation for the y-axis is what? It is simply x is equal to 0. Now we move on to the next topic. How many zeros can your polynomial have? It depends on the degree of the polynomial. The number of zeros always have to be less than or equal to the degree. Now, what is a zero? Zero is that value of x for which the whole polynomial is 0. But then, where did you plot the values of the whole polynomial? You plotted it in the y-axis, right? So, 0 is that value of x for which your y is 0. But then, what does this equation represent? This equation represents what? Your x-axis. So, it is that value of your x where the figure touches the x-axis. Now, the figure depends on what polynomial it is. If it is a linear polynomial, your figure will be a line. If your polynomial is a quadratic polynomial, your figure will be what? It will be a parabola. So, what are we going to prove? The number of zeros of the polynomial, the number of times the corresponding figure will touch the x-axis. So here what do you see? It does not touch the x-axis, which means this polynomial will not have a real root. It will have a root, but that root will not be a real number. It will be a complex number, and just two axes, the x-axis and the y-axis, is not enough. We need another axis, a third axis, which you will study in higher classes. But for now, it has no real roots. No roots which can be plotted using just the x and the y axis. So do not break your head trying to find a value. You will not get a real value for x. Now next, what do you have? How many times do you see the parabola touching? Exactly at one place. So this polynomial will have exactly one root. Now how do you find the roots? There are two ways to find. Either you split the middle term or you apply one of the identities. Out of these three, which can you rule out? Just by looking, which can you rule out? The third one. Why? Because you have a x term here. This one does not have an x term, so it is not this one for sure. Then which one is this? The first one. You can see that the 0 is 3. Technically, there is only one 0, which means where will the parabola touch? It will touch at the point 3, 0. Now, we go on to the next question. What do you see? You see that the parabola touches it in two places. One place is minus 2, 0, and the other place you can see is 4, 0. So, just looking at that, you should be able to tell that your polynomial has two roots. One is minus 2 and the other is 4. But then you don't have to believe me. You can try it out yourself. When you take that equation and you split the middle term, and then you will get something like this. Just looking at the parabola, you can find out if your original polynomial has any roots or not, and if it has any roots, what roots are there. You just have to find the place where they meet the x-axis, get the roots of the original polynomial. And there are a lot of other interesting things also. I don't want to go into detail because I'm following the NCERT syllabus, so I don't want to go into detail about this. But you see, this one is looking down and the others are looking up. Can you see the difference from the polynomials and guess why it is happening? You can see it here. If your a, you have ax square plus bx plus c, right? If your a is negative, your parabola will look down, and if your a is positive, it will look up. Similarly, you see the y-axis, the place where it touches, here is minus 1, the y-axis. The place where the parabola touches the y-axis here is 9. The place where it touches here is minus 8. Can you guess what is happening? See the C here? That is where the parabola touches the y-axis. Here it cuts, no? This place. So it's very interesting. Parabola is a very interesting subject. There is a lot to study, but as I said, I'm following the NCERT syllabus, so I'll just stop with this. Now that you have seen that we have three possibilities when we deal with a parabola, we will go on to a line and see how it behaves. If you start with a linear polynomial, you will get a line. A line, any straight line, will touch the x-axis in one point or it will not touch at all. Why is that? Let us see. Suppose you have a line, it goes like this. It will touch the x-axis only once. Now it will not go like this, change its mind and say, okay, let me touch the x-axis once again. That is not going to happen because what you have is a straight line. So maximum one time it can touch. But then what if it is parallel to the x-axis? What is the definition of parallel lines? Parallel lines are lines which however you extend them, they will never touch. So what is the equation for the x-axis? The equation for the x-axis is y is equal to 0. So these lines, this line will be which cuts here, this line will be y is equal to 1, y is equal to 2. Similarly, if it comes below the x-axis, it will be what? Y is equal to minus 1, y is equal to minus 2. You will have lines which are parallel to the x-axis, which means what? It will touch the x-axis 0 times. Not at all. It will not at all touch your x-axis. Now, from the line, if you come back to the linear polynomial, then you will think that either the linear polynomial has 0 zeros, no zeros at all, or it has exactly 1 0, right? You will think that there are two options, but sadly you are mistaken. Why is that? Let me explain. Why do you think so? Because we know that the number of zeros of a polynomial is less than or equal to the degree of the polynomial. So if the degree is 1, you would think that 0 and 1 are both options. But no, 0 is never an option. It is 1 and exactly 1. Why is that? Let me explain to you. Any linear polynomial will look like this, and it will come with a very important condition, which is a is not equal to 0. So if you equate y to 0, you will get x is equal to minus b by a. Now if a and b are both real numbers and a is not equal to 0, then minus b by a is a real number. You cannot say that there is no such real number. Suppose if I take, say, anything that you think of, for example, root 2 by pi. If this is a real number and this is a real number, then their ratio will also be a real number. You cannot say that I have an a, I have a b, but I do not have a b by a. That does not, that sort of an argument does not make sense, right? So if a and b are real numbers and a is not equal to 0, that is a very important point, because if a is equal to 0, then this whole thing will tend to infinity. So as long as your a is not equal to 0, if a and b are real numbers, then their ratio is also a real number. You cannot say that it does not exist. So please remember this question, not in 10th standard, but I've often seen this question in the 8th and the 9th standard question papers. A linear polynomial, you will think that it has two options. You will think that maybe it does not have a 0. You will think that that is one of the options, but it is not. Please remember, it is only for this, only for the linear polynomial. From that onwards, from degree 2 onwards, number of zeros will be less than or equal to your degree. From 2 onwards, it is correct. But this particular part, please remember, it has exactly 1 0. And what 0 is that? It is minus b by a. If this is your original polynomial, this will be your 0. Now, can you look at this picture and answer these questions? How many roots? How many times do you see the figure touching the x-axis? 3 places. 1, 2, 3. So your original polynomial, you don't know what that polynomial is, but for sure you can know that it has 3 roots. Then what are those roots? Look at the places where it has touched. One is minus 3, 0, the other is 0, 0, and the other is 5, 0. So that means what are the roots? The roots are minus 3, 0, and 5. And what is the degree of the polynomial? Now, do not get fooled by the question and say the polynomial is of degree 3. Don't say it is a cubic polynomial. Why? Because you have to remember that the number of zeros is less than or equal to the degree, which means if the number of zeros is 3, then the degree will be greater than or equal to 3, which means what? The degree can be 3, 4, 5, 6, whatever. All it means is that it has 3 roots. So what can it not be? It cannot be a linear polynomial. It has to be greater than or equal to 3. It cannot be a linear polynomial. It cannot be a quadratic polynomial, but it can have of degree 3, 4, 5, etc. And how will that look like? Let us just take a guess. Written down a polynomial here whose degree is 5. This is x cube, this is x, and this is x. Together its degree will be what? 5. But then when you equate it to 0, you get only 3 roots. This x cube is equal to 3, which means what? The 0 gets repeated 2 more times. So, but at the end of the day, it touches only at 3 points. At this point, 0, 0, minus 3, 0, it touches it at only 3 points. So, this is an example that we are looking for. With that, we come to the end of this topic. That's all for today. Inshallah, till I meet you again, you take care. Assalamu alaikum.